This is video number 1 for section 4.7, and in this video we're going to be looking at solving a few logarithmic equations, okay? So our first example actually has two different logarithmic equations to solve, and for both of these we are going to solve them based off of the property that we looked at last section that says if you have log base a of m equaling log base a of n, then that means the two arguments have to be equal to each other, okay? So basically, what we're going to do for both of these equations is use our properties of logarithms in order to make it so that I have a single logarithm equal to a single logarithm. And as long as those two logs have the same base, then we can effectively ignore them and just set the arguments equal to each other, okay? So for the equation over on the left-hand side here, 2 times log base 4 of x is equal to log base 4 of 16. What I'm going to do here is use my power property of logarithms on the left side here, and I'm going to make this log base 4 of x squared equals log base 4 of 16. Okay. Once I'm here, I can use the property written above and just set the arguments of x squared and 16 equal to each other. Okay. Now technically when you solve this you end up with two solutions, 4 and negative 4. Okay. But notice what I have typed up in red there on your screen. It says when solving logarithmic equations you must be aware of the domain. Well, we know that you can only take the logarithm of a positive value, right? Here, x has to be positive. So that means negative 4 is considered extraneous and should be ruled out. Okay, let's make a note of that. Negative 4 is not in the domain of log base 4 of x. Okay. All right, in my second equation, what we really want to focus on is that the left side of the equation has two logarithms that are separated by addition, okay? So the property written above it in blue, you cannot use that property right now because of the fact that we have two logs on the same side, okay? But I can fix that by using a product property of logarithms here. Right? I can take these arguments of x and x minus 2 and I can multiply them together. So I end up with log base a of x squared minus 2x equals log base a of x plus 4. Now I'm able to use that equality property of logarithms. I'll set the two arguments equal to each other. End up with a quadratic equation here. I'll move everything to one side. And then this factors to x minus 4, x plus 1. So I end up with x equaling positive 4 or negative 1. Okay. And you'll notice that the value of negative 1, if you were to plug that into the original equation for log base a of x or for log base a of x minus 2, it would make your argument negative. So you're going to have to rule that one out. Okay. Common mistake that I see from students is they think that for all of these logarithmic equations, that all negative answers are extraneous solutions that need thrown out. That is not always the case. It's just a question of whether or not once you plug that value back in to your different arguments of each logarithm in the equation, it's whether or not it simplifies to a negative value. So just be careful about that. Okay. All right, in our next example, that's another logarithmic equation, but kind of inspect that, and hopefully you're noticing something different about this from the last two equations, okay? And the difference is that the right side of the equation does not have a logarithm to it, okay? So that is going to require a different approach than what I did on the last two equations, okay? I'm not going to be able to use that logarithmic property of equality, okay? So instead, what I'm going to do here is I'm going to condense the left side of the equation. I'm going to multiply these two arguments together using a product property again. So that's going to lead me to log base 2 of x squared plus 8x plus 7 and just equals a plain old 3. All right. Now, at this point, you can't just ignore log base 2 in front of x squared plus 8x plus 7 because over on the right-hand side, you don't have log base 2 of 3. Okay. Again, that's just a plain old 3. So our approach this time should be moving to exponential form. Okay. This logarithm has an exponential form of 2 cubed equaling x squared plus 8x plus 7. All right. 8 is equal to x squared plus 8x plus 7, where 0 is equal to x squared plus 8x minus 1. All right. And then this one you'll end up needing to use the quadratic formula or completing the square on. It ends up being x equals either -4 plus or minus the square root of 17. And let's approximate those. So if it's -4 plus the square root of 17, you end up with approximately 0.123. If it's -4 minus the square root of 17, you end up with -8.123. Okay. Now make sure, are either of those solutions extraneous, and it just so happens that the value of -8.123 is. So here is my only solution. Okay. So once again, want to draw your attention to the fact that in order to solve this equation, the main idea here is that I had to go from logarithmic form into exponential form. Okay. That's the underlying idea here. Okay, that's it for this video.